Okay, so I thought I'd do this question 5 from day 2 of the past paper. A bit of pims and columns, maybe just pims. Cool, so we're looking at making some numbers using those digits there, which are all different digits, which is all good. This one's going to be in more detail than the quick review, so I hope that will help you a little bit more. So all 7 digits are, for part 1, all 7 digits are used, and the odd digits are together, and no digits are repeated. So if I put the odd ones together, that's 1, 3, 5, 7, and 9. So that leaves 4, and it leaves 8. Okay, so those are my 3 groups I'm going to use to arrange it initially, which means it's 3 factorial ways that I can keep all the odd numbers together, not repeat the digits, and arrange those 7 digits, right? But within this group here, there's 5 factorial ways that I can arrange them. So I'm told it's going to be 3 factorial times 5 factorial, which if I just do that quickly on my calculator, oops, is 720 ways that you can do that. Okay, so that's part 1. Then for part 2, they want even numbers. So, and you still can't repeat digits. And it's got to be between 3,000 and 5,000, which means you're going to go for any digits that start with a 3, and any 4 digits, any 4-digit numbers, that start with a 4. And what you want to do is, I guess, what I like to do is make a bit of a diagram of what the possible outcomes are. So, if I want 4-digit numbers, and I want them to be even, in this case here, it could start with a 3 and end in a 4, or it could start with a 3 and end in an 8. But here, when it starts at a 4, the only other option is for it to end with an 8. So they're fixed. Okay, I'm not going to multiply by those. That's just me spacing out what I need to do to find out how many different ways I can make this happen, the structure of it. And now I'm going to go back and I'm going to look at how many ways I can arrange the digits within those 2 fixed values. So if we look in here, if I'm using a 3 and a 4 there, that leaves me 5 digits that can go in the middle. So 5 can go there, and that leaves 4 that can go there. Okay, and that's the same all the way down here. Okay, which means basically I've got 20 plus 20 plus 20, so 60 different ways. Okay, that's for part 2. Okay, and then for the last one, the only thing we've got to watch out for here, it's a little bit different from what we've been doing before, is just to make sure that we take into account any of the numbers that are less than 1,000. So numbers that are less than 1,000 can be 3-digit numbers, or they could be 2-digit numbers, or they can be 1-digit number. Okay, and we want multiples of 5. So in each case, we want to fix the last position as being a 5 there and there. Okay, so that's fixed. We're not going to multiply by 5, and what we want to do is look at how many other ways we can arrange the digits around that. And the key thing here is now we can repeat digits. Okay, which means we've always got 7 to choose from every single time we're placing a digit into one of those spaces. So for example here, that's going to be 7 times 7, because I can put 7 digits in the first spot, another 7 digits in the second spot. Then here that's going to be another 7 ways. And there's only one 1-digit number, that's a multiple of 5, which is 5. Okay, so that's going to be 49 ways for that one there, and 7 ways for that one there, and 1 way for that one there. So when you add that all up, you're going to get, for part 3, 57 ways.